Okay, so just to give you another example that you can work through with function notation and properties of functions, I have a graph for you here, and let's just answer these questions about it. So we want to know the horizontal intercepts, the vertical intercepts, where it's increasing and decreasing, and the locations of any local maximums or local minimums. So you can take a second, you can try this out on your own if you want. So go ahead, pause the video, and check that out now. I will walk through our solutions here. So for horizontal intercepts, I want to look at where it crosses the horizontal or x-axis. I'm seeing at -5, 0. And again, it doesn't really cross there, I guess it just touches, but there is a point on the axis there, and that's what matters. So our horizontal intercept is -5, 0, and it's just the one, we don't have any others. Next, for the vertical intercepts, we want to look at where the function crosses the vertical axis or the y-axis. I'm seeing that that happens at 0, 4. So 0, 4 is my vertical intercept. Next, I want to look at increasing and decreasing. So I like to break up the horizontal axis into parts so we can see which part does which. So for the first part of the graph, I am decreasing all the way until I get to -5. Again, I see that since I'm sort of going downhill as I walk from left to right. Then for the next portion of the graph, I am increasing. So from -5 up until -1.5, I am increasing. Then I decrease again from -1.5 until I get to 1. And I increase from 1 all the way to the end of the graph to infinity. So writing those answers as intervals, I am increasing from -5 on the x until -1.5 on the x. And I am also, so with a union for also, I am also increasing from 1 on the x to infinity. Then the decreasing answers are the other intervals, so I am decreasing for the first part, so from -infinity to -5 on the x. I'll use a union symbol again. So from -1.5 on the x to 1 on the x, we are also decreasing. Also, I'm not totally positive it's exactly 1.5, but for now we're just estimating based on what I can see on the graph. Then our local maximums and minimums occur when we're switching from increasing to decreasing or vice versa. So we can answer our local maximums and minimums by using what we figured out with the increasing decreasing. The maximums will occur when we change from increasing to decreasing. So that's at this point here at -1.56. And the local minimums occur when we change from decreasing to increasing. So there are 2 of those. So I see one at -5, 0 and at 1, 2. Okay, so just some comments, things I want to point out with this example. So all of these answers have parentheses in them, but some of these things are intervals and some of them are points. So there's really no way to just look at it without context and tell which is which. The union symbol lets us know that they're usually intervals, but you just need to know the context in order to tell what's going on. So we think of an intercept, for example, as a point. So I know that those answers are points, they're coordinate pairs. So that's how I tell that those are points, not intervals. Then for increasing, decreasing, we always use intervals for those answers. So I know those are intervals. So for maximums and minimums, those are points on my function, so they're ordered pairs, coordinate pairs, so that's how I also know that those are points. So there's really no way to just look at it and know. You need to know the context to know what the math means. Alright, that's it for this video. I will talk to you in the next one.